So now that we have looked into autocovariance and autocorrelation, we'll also look into cross-variance and cross-correlation. So instead of looking to the same variable, so we just looked at NDVI, if NDVI values from previous time affect or not, or are correlated or not with NDVI at the current period. We can also do the same analysis, but looking to two different variables. So in this example of section 2, we'll actually looked how, like, if precipitation is correlated with NDVI or not. So we have two time lags, 5 days and 30 days. And for precipitation, we use CHIRPS data. So we'll look if precipitation from 5 previous days are correlated with NDVI values at a present time period, and compare that as well with 30. How much 1 month of rainfall influences NDVI at a current time in our time series. And the only code change in code, we'll see this in the code editor, but the workflow for 5 days is exactly the same as we've seen for the previous section. And then the only change between 5 days and 30 days here in terms of code is we won't need to use the iterate function, and we'll see how. So I'll go back here to the code editor. I will open F49B, and then yes, I want to abandon all changes. And everything here is exactly the same. So just pass through this. This is all that we've done. We have all of our functions here defined, the one to create a lagged collection. We have the merger one to add the previous NDVI band, and we have functions to calculate covariance and correlation. So section 2 starts here in line 184. The first thing we're doing is just getting our CHIRPS image collection. So this is the precipitation data that we do. This is our covariate. We are seeing how, if this has correlation with the NDVI value or not. And this data set is the lag time that will start with 5 days. So what we'll do, we'll create a new variable here. It's lag 1. It could be lag 5 since we're working with 5 days, but it could be lag 1 because we are working with 1 pentad, which is 5 days, and then precipitation and NDVI because we're looking to these two variables, how they are cross-correlated. And then what we do, we use that lag function to actually create a lagged collection. But in this case, instead of using the detrended time series, we are using the original time series as our first image collection. And then the second collection is not the same Landsat 8 surface reflectance, right? We're not looking to autocorrelation, we're looking to cross-correlation. So we're looking to precipitation in this case. So we define here CHIRPS, and then 5, because we're looking to a 5 lag period, 5-day lag period. So this is done. Here's exactly where we're creating our lagged collection. In this case, every image will have a property called images, which will be the CHIRPS image added to that Landsat 8 image. The second thing, we don't want the band of CHIRPS to be a property, a band within an image, within a property of an image. We want it as a band in the image. So we use the merge function as well that we have defined. So this line is just adding the CHIRPS precipitation data band as a band in our Landsat image. And then because we also define covariance function, we just need to apply that covariance function to our new variable, which contain NDVI and then precipitation at a lag period of 5 days. So here, the band is NDVI, and then our lag band is precipitation. And then flipping to the region of interest, And then as we see, we need to use this array get to get the covariance of that array of 2x2 array. And then the same thing for correlation. We take the covariance and then we apply the correlation function. So here's the covariance, and then we use the correlation function to calculate from the covariance. And I'll comment the rest of the code just to see the results. So since we've done all of this, define all the functions here needed to calculate covariance and correlation. To calculate between NDVI and precipitation is pretty straightforward. We're just applying the functions that we had previously defined. So I'm gonna turn off these first two images, which are the ones from the previous session, and I'll just leave the images here that we have just created, which are computing correlation and covariance between NDVI and precipitation with a lag period of 5 days. So the one here at the top is the correlation. So the brighter pixels will be the ones that have precipitation 5 days prior to that NDVI value with higher correlation, and then darker pixels that have lower correlation. Let me see if the image is here. Yeah, it's this one here at the top. I'll just show you in the slide because it will take a moment to load. So we know that, you know, these areas that have white pixels, the correlation is greater than the ones that have here lower correlation values or darker pixels. But what happens if we change that lag period from 5 days to 30 days? Do we think it will influence more? It will have a higher correlation? Here we're just looking at a very short period. How much would precipitation in the last 5 days influence the NDVI value at present? So this is the result, and then we can compare that with a greater lag period, which is exactly what we do next. We calculate, instead of using 5 days, we looked at 30 days, right? And I think it is expected that, you know, that will influence much more our, you know, precipitation. When we're talking about crops, usually you know, more precipitation is good. So more, it should have a higher correlation in the end. So what we are doing here is exactly the same thing. We calculate our lagged precipitation NDVI time series, but here we use 30 instead of 5 here in a lag function. And then instead of using that merger function that we have used before, what we need to do first is actually sum all of the precipitation values in 30 days together. So we have just one value of precipitation in that 30-day time period. So we don't need to use that merge function anymore. We just do straight, we can just do this using this code block right here, where we grab our lagged images here will be our precipitation images. So all the images that are 30-day apart from a current image are stored in the property images. And what we do, we just sum all the precipitation values of all of those images at each pixel and add the resulting sum value as a band to the current image. So we don't need to use that merge function. And then here we do the same. We use the covariance function to calculate covariance, and then correlation function to calculate correlation. And then this will also take a while to load, but I can show here that using the same min and max values, we can see that, you know, precipitation from 30 days is higher. This has more correlation with the present NDVI value compared to precipitation with, you know, from only 5 days. So I'll stop here if there are any questions.